So Chapter 2 is still technically part of Unit 1. So the way AP Stats College Board is arranged, they arrange it by units. Our book breaks it down a little bit differently so that we can kind of chunk ideas rather than having these enormous tests. So this is still part of Unit 1, but it is Chapter 2. We're going to be exploring one variable data still. And I want to introduce you guys to a new type of visual representation for data, but we're going to start with an older piece. I want to describe this distribution. We're going to work on how does your height compare with other AP students. So this dot plot here represents a random sample of the heights of 20 AP Stats students. So we've got the graph, and we have our summary statistics. How would you describe, using SOCS, this distribution? So let's start with shape. How would you talk about the overall shape? Approximately symmetrical. Anything else stand out to you about it? There might be outliers. Yeah, we've got this guy and this guy. Does anything else pop out to you about the shape? Yes. Yeah. It does seem to have two distinct bumps there. Okay, so let's start our description. First, I need my context in here. What is this a graph of again? Height. What'd you say? Height in inches. Height of who in inches? Yes, so we want to get all the context we can in here. Saying height will probably get you safe, but just to make sure, you want to include all the context you possibly can. So the distribution of heights of 20 AP Stats students is fairly symmetric and bimodal. And then before we say anything about possible outliers, we know how to actually check for outliers now, right? Let's grab some calculators and check to see if those two, the 56 and 78, are outliers. So we've got all of our summary statistics right here. What's the IQR come in at? 4.5. So to check for our outliers, we're going to do Q1 minus 1.5 times our IQR. And Q3 plus 1.5 times our IQR. That means our lower boundary comes in at what? What is the Q1 minus 1.5 times IQR? 58.75. And what about when we do our upper boundary? You got 76.75? It's possible that I typed it into my calculator wrong. Did other people get 76.75? Okay, like I said, I probably typed it into my calculator wrong. No problem. 76.75. Oh, yep. I had 1.2. I slipped and hit the 2 instead of the 1.5. All right. So are the 56 and the 78 actually outliers? Yes. 56 is smaller than 58.75. 58.75 would be right about here. There's my outliers. And 76.75 about right here. Okay, so to finish this sentence off, I said the distribution of heights of 20 AP Stat students is fairly symmetric and bimodal with 2 outliers at 56 inches and 78 inches. All right, so I've got one sentence and I've hit how many pieces of socks? I've hit 2 pieces. I've hit shape and I've hit outliers. Remember, it doesn't matter where in these sentences you talk about these pieces. I just thought it looked like a good spot for us to stick that in because it was mentioned as we were talking about shape. All right, so we've got shape, we've got outliers, center. Should we use mean or standard deviation here? Or sorry, not mean or standard, mean or median. Let me get my measures of center right. We've got mean or median. I'd be fine going with mean because it is symmetric, and even though there's outliers, there's one on each side, so it's kind of pulling it both ways. So I would say it is centered around the mean of, what is our mean? 67.45. Now give me some context to go with that. 67.45 what? Inches, yes. Centered around the mean of 67.45 inches. Do you think they would take points off on the AP exam if you used the median here instead of the mean? No. I could make an argument that because the outliers are present, that we'd feel more comfortable using the median as the measure of center. And if you look at the mean and the median, what do you notice about those two? They're really close together. When the mean and the median are really close together, you're probably safe using the mean to talk about the center. When they're very far apart, when the mean and the median have this discrepancy, that's when I would trust the median because it's most likely skewed or has outliers that are affecting that. And then what else do we need to hit? Variability, which is also known as spread. What should we use to talk about the spread? Standard deviation. Since we decided to go with the mean to talk about the center, we're going to go with the standard deviation to talk about the spread. If we had chosen the median to talk about the center, what would we use for measure of spread? IQR, yes. Okay, so the standard deviation is 4.807, and then a period? Inches, thank you. Inches and then my period. Always stick units on everything. If it's got a unit, put it on there. Otherwise, like imagine you handed this to someone and you said the standard deviation is 4.807 and they go, kittens? Like 4.807 what? What does that mean that the standard deviation is 4.807? Yeah, so I want to kind of look up here. Our mean is 67.45. 67.45. So our mean is like right about-ish here. I'm just kind of ballparking this. standard deviation is 4.8, so 5, right? So what's 67 plus 5? 72? So it'd be like 72.5, so yeah, right about-ish here is 1 standard deviation away from the mean to the right, correct? And then 67.45 minus about 5 would put me at like 62 and a half. 62 and a half would be like right here, right? This is 1 standard deviation away. Do my points typically fall within that far away? Are most of my points in there, in between those fences? We've got some points that are further away, but remember, this is talking about on average how far away my data points are from the mean. That's what this is trying to express. All right, let's look down at number 2. It says Ariana is 65 inches tall. What percent of the heights are less than or equal to 65? How many people in this distribution have heights that are less than or equal to 65 inches? Yes, sir. About 25%, because you came up with how many dots? Well, let's go ahead and count the dots, because we actually can see all the people here, right? Let's see, 65 inches would be this guy right here, right? So there's 1, 2, 3, 4, 5. So we've got 5 dots that are at or below 65 inches. So 5 out of how many kiddos again? 20. 5 divided by 20 comes out to be 0.25. So 25% is absolutely correct. I want you to fill in your height and determine what percent of the heights on that distribution are less than or equal to your height. I'm going to do this for mine. See, I am. If anybody needs help converting their height from feet and inches into just inches, 5 feet is 60 inches. So if you're 5 feet 6 inches, you would be 66 inches tall. I'm 5'7", so I'm 67 inches tall. If you're over 6 foot, it'd be 72 plus your inches. So let's see, I'm at 67. 10. Right. So mine came in at the 50th percentile. Or sorry, 50%. No. Does that make sense with where we said the median was? Median was 67.5. So if I look at exactly 67 or smaller, I came up with 10 of the kids. And that makes sense. 10 same height or smaller than me, 10 kids taller than me. Same height or smaller. I want to fill in this frequency table. And then we also have relative frequency and what's called the cumulative relative frequency. So frequency, remember, this is counts. How many? So I want how many people, how many dots are there between 56 and 60 inches? How many people on the dot plot are there between 56 and 60? Just one dot. How many people are there on the dot plot between 61 and 65? 4. Between 66 and 70? 11. Between 71 and 75? 3. And between 76 and 80? 1. Do you guys remember how to do frequency? Frequency is our percent. So let's take the frequency and divide it by however many people there are. That gives me how many percent of people there are in that window. So I'm going to do 1 divided by 20, which comes out to be what percent? 5%. And then we have 4 out of 20, 20%. And then 11 out of 20, 55%. 3 out of 20, 15%. And then we've already done 1 out of 20. That was 5%. What do you think happens if we add all those percents up? Adds up to 100%. If I include all of the dots, I've got 100% of the students, right? Okay, so relative frequency. Cumulative relative frequency. Cumulative relative frequency. Does anybody know what this word means? If your teacher says the final exam is cumulative, it's over all the material that you've studied up to that point. Cumulative is everything from the beginning up until where we are right now. So we're going to keep adding stuff on. If your final exam in the spring is cumulative, it would go from August all the way to May. Right? So our cumulative relative frequency for 56 to 60, if I start at the beginning of the graph over on the left-hand side, and I go over to 60, we've only managed to grab one person, right? So 5%, 1 out of 20, 5%. If I go from the beginning of the graph on the left all the way over to 65, how many people have we grabbed now? 5. And 5 out of 20 is 25%. Notice that's exactly the same as if I just add the percents together. I can add the people together and divide by 20, or I can just add those percentages together. And I get that cumulative from the beginning up to this point frequency. How many people have we gathered when we extend it all the way out to 70 inches? 16 people. And that would put us at what percent? 80%. Notice that's what we get if I add 5 and 20 and 55, or 25 plus 55. I get up to that 80%. If we add 3 more people, now we're at 19 out of 20. And that would take us up to 95%. And then we get up to the last person. Now we have everybody 20 out of 20. So I am at 100%. We are going to take these numbers here in purple, and we're going to make what's called a cumulative relative frequency graph. So far, so good? All right. Cumulative relative frequency. So in between 55 and 60 inches, we had what percent? So remember, these are all percents here since we're talking about relative frequency. What was the percent in between 55 and 60? 5%. So I don't want you guys to copy this down just yet. I'm just going to kind of put something in the background so that we can look at it, and then we'll make this graph. So I'm going to treat this almost like it's a histogram here, okay? So I'm going to take this up to about the 5% mark, right? And then when we got over to the next group, what was our cumulative relative frequency? 25%. So if I take this up to about 25%. And then 65 to 70, we jumped up a lot and went up to what? 80%. 80% is way up here. And then 70 and 75, when we went that far over, we were now at 95%, so almost up at the very tippy top. And at the very end, we got up to 100%. Let me try to find a different color now. Let's go with pink. Okay. So this is kind of what a histogram would look like, right? If I was plotting the percents on a histogram. What percent of students were smaller than 55 inches? 0. So I'm going to put my first dot here at 55, put that at 0. We had nobody smaller than that. My next dot is going to go at the 5% mark. And then I'm going to connect those two with a line segment. Between 60 and 65, now we jumped up to 25%. I'm going to connect the 60 and the 65 dots together. Once we made it all the way over to 70 inches, we now had 80% of all the dots, all the people. I'm going to connect those with a line segment. And then we went up to 95%. And we ended at 100%. So what I did in black is the cumulative relative frequency graph. It looks like a bunch of line segments strung together that when you squint at it almost has a curved appearance to it because we've got all these little line segments joining each other. A cumulative relative frequency graph will always start at 0 on the left, and we're always going to end at 100% over on the right because we want to get everybody. What do you think it means that this segment right here has the steepest slope? What does it mean just in Algebra 1 when you have a slope of a line that's really steep? What would that mean about the rate of change or the slope? Yeah. So this increased really quickly here, right? Steep slope increased quickly. We have many values between 65 and 70. We have a bunch of people, a bunch of dots here. I can use this cumulative relative frequency graph now to determine where different individuals would fall in this distribution without including them in that original data. And this idea is what we would call a percentile. So I want to go higher up on the page for just a second. This 25% right here, we would say that Ariana is at the 25th percentile. Have you guys ever heard that word percentile before? I know I heard it a lot when my kids were going to the pediatrician and they would look at their height and their weight and they would say, your child is in the 50th percentile for weight, but the 14th percentile for height, or something like that. I've also seen percentiles talked about when you get standardized test scores back, like when you were in elementary school and you had to do like the iLearn and the iRead and the NWEA, and I don't even remember the names of all of those. They test you guys too much. But they talk about your percentile, which tells you how you place compared to the other people that took that test. Or in terms of like your height and weight at the doctor's office, it tells you where you place in comparison to other people that are about your same age. How does your height compare to their heights? How does your weight compare to their weight? And we always say that it is at, never in. We don't say we're in the 25th percentile, we say we're at the 25th percentile. The reason for that is it's a location. Do you guys remember in geometry when you learned about points, lines, and planes? A point has no width, no height, no dimension. It's defining a location. When we talk about percentiles, we're saying that you're at this location. You can't be inside of a point. You can't be inside of a dot. That's why we can't be inside this percentile. It's going to be a dot somewhere on that cumulative relative frequency graph. So I want to use that now. This one should be a little bit easy since I already did mine up on the screen, but I want to show you how I use the cumulative relative frequency graph to find the percentile. It says Ms. Bolt is 67 inches tall. Estimate and interpret her cumulative relative frequency. So I have to find 67 somewhere along the bottom. And I need to try to find a good color to do this in. Let's go with green. So this would be 67.5, right? Halfway in between 65 and 70. So 65 would be just a little bit to the left of that. So I'm going to follow this up. Until I hit that cumulative relative frequency graph, making this as straight as I can. And then from there, I'm going to follow it over to where I can read that percentage. Looks like it's falling about where? If I actually put this in the right spot. It's falling at right about 50%, right? So 50%. And then interpreting that, I would say 50% of students are at or below Ms. Bolt's height. All right, let's do part B. Estimate and interpret the height that has 60% cumulative frequency. So I'm going to start at 60%. I'm going to take that over to my graph. And then I'm going to follow that down to my x-axis. Looks like it's a little bit bigger than 67.5, so you'd ballpark that at what? Yeah, I'd probably call it 68 since it's just a little bit bigger than 67.5. I guess that would depend on what my given information was. If I was asked to estimate the percentile, then I would use an about. If I was told, which we weren't necessarily told that here, but if I was told Ms. Bolt is at the 50th percentile, interpret that meaning in context. Now I have an exact value that I was given. And then I would say this sentence right here. I would have it be precise. Yes. I would say if you used the word about, it's not going to be wrong. Estimate and interpret. So we said about 68 inches. What does that mean then? What does it mean that 68 inches has a 60% cumulative relative frequency? What does that mean in this particular context? That's exactly what this means. 60% of students are at or below 68 inches. Or I could have said something that means the same but sounds a little bit different. If I say that 60% of students are at or below 68 inches, I could also say, what about people taller than them? 40% would be taller. Did you have a question, Jerry? Yeah. 40% are taller than 68 inches. All right. That pretty much wraps up what we're trying to get through today. We're going to turn it over on the back. We're going to review our big concepts, and we're going to practice to see how well you are understanding this new concept about a cumulative relative frequency. So percentile, the number percentile, they said piece percentile. You put the percent in there, and then you put usually a TH unless it ends with a 1, 2, or 3, right? First percentile, second percentile, 13th percentile is the value that has that percent of data less than or equal to it. So again, I want you to think about standardized scores or going to the pediatrician when you were younger. That percentile, they're telling you where you fall in that distribution and what percent of people are at that or below. So if you score in the 98th percentile on your standardized test, what would that mean? If you score in the 98th percentile. That's the percent you're at. Yeah, so everybody else that took that test, 98% of them got your score or lower. 2% got more than you. That's what the 98th percentile would mean. 98% of all the people that did that test got your score or less. And again, we say we're at a certain percentile, we're never in percentiles. Cumulative relative frequency graph always has kind of this choppy look to it because that's always line segments that are being connected. We always start at 0. We always end at 100. Here they wrote their percents as decimals, as proportions, so they have it ending at 1 instead of 100%. It's the exact same idea. They just wrote their percents as decimals instead of percents. We can read our 5-number summary off of a cumulative relative frequency graph. If I go to 50% on the y-axis, I can follow that over and then down to the x-axis to find the approximate location of the median. What would I be looking for Q1? What percentile? 25th percentile. Q3? 75th percentile. So I can use a cumulative relative frequency graph to find a measure of center. If I can find Q1 and Q3, I can find a measure of spread. I can find the IQR. I can even look to see if some things would be outliers, because remember, we start at 0 and we end up at 100%. So I would know my maximum and my minimum also. We basically get our 5-number summary from this. I know where it starts, I know where it ends, I know where the 25, 50, and 75% mark is. I want you guys to try to check your understanding. There's 2 questions there. I want you to try both of them. Let's take about 5 minutes and see where that puts us. Your understanding right now. Got a couple minutes left for some independent work time. So what's it mean when we say the state of Pennsylvania was at the 82nd percentile for pre-K to 12th grade education rating? Yes, sir. Mm-hmm. Yeah, 82% of the states have a pre-K to 12th grade rating that is less than or equal to whatever Pennsylvania has, where they are as good as or better than 82% of the other states in their K-12 education or pre-K to 12 education. What does it mean they're at the second percentile for higher education rating? Should they be proud of their 2% rating for higher education? Why not? Why is it bad? What's it mean? They're better than only 2% of the other states, or the same or better than 2% of the states. So if we're saying 2%, anybody know what 2% of 50 is? So yeah, they're pretty low. K-12, you're good. Go out of state for college. All right, cumulative relative frequency graph. Let's go on to number 2. The graph displays the cumulative relative frequency of the cost of in-state public college education for each of the 50 states. I actually don't like the way they drew this because they got it wiggling in here, and typically we have those straight line segments. So when they made this, they must have had more data points to fill in because that curve would be made up of a lot of little dots. So they must have had a lot more to work with. About what percent of states have in-state public college tuition less than or equal to $8,000? About 60, yeah. So what about more than 8,000? 40%. So about 60% of states have tuition that's less than or equal to 8,000. About 40% of the states have tuition more than 8,000. What about part B? Let me pull up that question. Same graph, but now we want to find what? Q1, Q3, and IQR. Q1 looks like it's probably about where? 4,000 for Q1? Q1 would be what percent? 25%. So looking at my graph, 30 would be right here, right? There's 30%. So 25% is going to be about here-ish. I'm going to follow that over. I think it's going past 6. And I try to be as straight as I can, like the edge of a book or a folder or a straight edge if you've got one to follow it over. That puts it more like where? More like 6,000. What about Q3? What'd you say? About 10,000. 75 is going to be about-ish here. Follow that over and take it down. Looks like it's at about 10,000. So Q1 is 6,000. Q3 is 10,000. So what's our IQR then? $4,000, yes. Q3 minus Q1 gives me 4,000. We are finishing up early today. Yay. I don't have your tests graded yet. I'm going to work on them tonight. If I don't have them done by the end of tonight, then I will definitely have them done by Monday. Typically, I try to have that turnaround time really fast. This time around, my geometry kids took a quiz on the exact same day, and their test is tomorrow. So I wanted them to have some feedback on their quiz so that they could prepare for their test. But most of the time, I'll have things graded in 24 to 48 hours. You'll see grades go in over the weekend if I don't get them up tonight. And then next week, I will give you a chance to look at it. We can talk through all of the problems, answer any questions that you guys have, and go from there. Your homework is due on Tuesday. Homework's due on Tuesday. Anything having to do with percentiles or cumulative relative frequency off the homework, you guys can do. If it's any of the other stuff and you've read ahead in the book and you want to try it, go for it. But we'll be covering Monday or tomorrow and Monday the rest of what you need to be able to finish that homework up. If you haven't finished the reading yet, now would be a good time because we've got a couple minutes left at the end of class. You can get some of that reading knocked out.